am Shivansh Dubey and I am uploading the second part of our motion series on my channel. Know that. Because of some problem I have taken a long time to upload second part, so really sorry for that. In the first part we have discussed about motion and rest. If you don't have watched that video, so first of all check out that video and then watch this video. So without any further delay, let's start. So in the previous video we had discussed motion and rest. So today we will start from types of motion. So जब भी हमको कोई चीज स्टडी करते हैं तो पहले हम उसको क्लासिफाई करते हैं. मोशन को भी हमने क्लासिफाई किया है दो बेसिस पे. पहला जो हमारा वो है ऑन द बेसिस ऑफ पाथ और हमारा जो दूसरा है वो है ऑन द बेसिस ऑफ डिस्टेंस कवर्ड. तो ऑन द बेसिस ऑफ पाथ देखते हैं. रैंडम मोशन, जो रैंडम मोशन होता है, रैंडम मोशन को हम बेसिकली कहते हैं कि व्हेन अ बॉडी ट्रैवल्स विथ एन अनडिफाइंड पाथ, यानी वो रैंडमली किसी भी पाथ पर अगर बॉडी आती है उसका कोई डेफिनेट पाथ नहीं होता है, तो हम उसे कहते हैं रैंडम मोशन. सेकंड है हमारा ट्रांसलेटरी मोशन. ट्रांसलेटरी मोशन यानी वी कैन बेसिकली से दैट when a body is moving and its every particle has equal displacement and on the same trajectory, then you will say the body is with translatory motion. Translatory motion are two types: rectilinear motion and curvilinear motion. In rectilinear motion, the body travels along a straight line, but as in curvilinear motion, the body travels in a curved path. Next one is rotatory motion. In rotatory motion, any object rotates. For example, our Earth, which rotates on its axis, because this phenomena there is day and night. And we can take example of fan, which rotates on its axis. These are the example of rotatory motion. Next is our oscillatory motion. We also know this as vibratory motion. In oscillatory motion, we had seen the pendulum of a clock. It is known as to and fro motion. The to and fro motion is the motion which is defined by the pendulum of a clock or a guitar string struck by a guitar. In the pendulum of a clock, it runs like this. To and fro motion. This one is called to and fro motion. And the to and fro path is known as oscillatory motion. On the second basis, we classify the motion in uniform motion and non-uniform motion. Uniform motion is nothing but when a body travels equal distances in equal intervals of time. For example, suppose a body is here and it starts moving. Now it comes here. The distance between this point and this point, let be 1 meter. And the time take to travel from here to here be 7 seconds. Now again it travels from here to here, and the distance between this point and this point let be 2 meters, and the time taken to travel from here to here is 14 seconds. So means when body travels 1 second, basically we mean if a body travels 2 meters in 14 seconds, then it will travel 1 meter in 7 seconds. Then we know that a body travels 1 meter in always in 7 seconds, and the body is with uniform motion. And non-uniform motion is just opposite to uniform motion, when a body does not travel with equal distances in equal intervals of time. For example, if body is falling, you know that a ball when it falls from your terrace, and you just leave the ball to freely fall. First, in 1 second it will come here, in second it will here, third it will here, fourth here. So it is traveling unequal distances in equal intervals of time. So it is with non-uniform motion. So our next topic is distance and displacement. First of all, distance. So distance is basically defined as the length of the path traced by an object. So for example, a body travels in this way. So this is the path of the line. First of all, in this direction, then in this direction, and then this direction. So what will be the total distance? The total distance will be the length, the sum of the length of this line, and this line. If we will find the sum of the length of these lines, we will get the total distance traveled. And displacement is the shortest distance between 2 points, or the directed line which connects 2 points to initial, that is initial point and final point. So in this way, the displacement will be this line, the length of this imaginary line. When we will connect these two lines, then we will get the displacement. And if we have to find, for example, here is distance, and this one displacement. Will always be greater than displacement, either equal to displacement, and it will always be positive. Distance will always be positive. Whereas displacement can be positive, it can also be zero and negative also. Now, how it will be? For example, if we go to the market, so this is our way. We go in this direction, then in this direction, and so our distance will be length of this line and this line, and we also come back. So suppose the market is 5 km, that's 3 km this and 2 km this side. So total distance is 5 km. Suppose the market is 5 km. And we go to market and also come back to our home. This is our home and this is market. So when we will come back to the home, our total distance traveled will be 10 km, because 5 km going and 5 km coming. So, but if we will have to find the displacement, then it will be 0. But how? Because that when we will go to the market and come back, then we will on the same point, that's our home. So when we will our home, the initial point and final point are same. When the initial point and final point will be same, the displacement will be 0. Now if we have to find the prove that how distance can be greater than displacement or equal to displacement. So if we know that in this line, the sum of these three lines, for example, we go in this direction, then in this direction, this will be a right angle. This is will be this. Now the displacement will be this line. We know that the Pythagoras theorem, the sum of the square of this line and this line, the length of the square of this line and this line will be equal to the square of this line. But the sum of these two lines will not be equal, because we know the property that the two sides, so the sum of two sides of line is always be equal to the third side. So now we know that how distance will always be greater or equal to displacement. Or how equal to displacement? If we travel in a straight line, that's a rectilinear motion which we have studied. If we travel in a straight line from here to here, the shortest distance between initial point and final point is this one only, and so the distance and displacement will be equal. And if we how it can be negative? For example, we go to somewhere from here to here and then come back from here to here. So the distance, if we have traveled opposite direction, so it will be negative. And if distance can be 0, I have told, and displacement can also be 0, I have told. So now I will solve some questions on this topic. some questions on distance and displacement. So our first question is that a man travels in east direction 3 meter, then in south direction 2 meters, and then finally in west direction 1 meter, and we have to find total distance and displacement. So given है कि एक हमारे भाई साहब हैं, तो थोड़ा सा चलते हैं बस एक क्वेश्चन देने के लिए हमें, ठीक है, घुमा लेते हैं, सॉरी। तो पहले वो चलते हैं कितना 3 मीटर, मार्को कहूँगी ये बात अच्छी नहीं लगी, सॉरी अंकल। तो पहले वो चलते हैं 3 मीटर, फिर वो चलते हैं कितना 2 मीटर in south, this is in east, this is in south, and then he travels how much? 1 meter in west. So total distance will be, this is basically the length of the path, so the total length will be 3 meter plus 2 meter plus 1 meter. As 3 plus 2 plus 1 is equal to 6. 6 meter is our, we can say, distance. Now we have to find the displacement. So first of all, we will draw the direction graph. North, west, east, south and west. So first of all, it is given that it travels 3 meter in east. Draw line equals 3 meter. Then it travels 2 meter in south. 2 meter. Then it travels 1 meter in west. 1 meter. Distance is already 6 meter. We have to find a displacement. So we will first draw a line perpendicular. First we will mark the points A, B, C and D. We will draw a line perpendicular to AB which touches the point D. This angle will be 90 degree. So we know the Pythagoras theorem. So we will apply Pythagoras theorem in it. We know that this is 1 meter and this hole is 3 meter. So this will be 2 meters and this is 2 meter. So this line also means 2 meter. We will mark it as E. So if BC is equal to 2 meter, then ED is equal to also 2 meter, and if AB is 3 meter and DC is 1 meter, so this one which is AE will be 2 meter. So we will solve this question. We know that the Pythagoras theorem and AD square equals AE square plus BC. So AD square equals how much AE is 2 meter. Then how much this one ED, sorry, it will be ED square. So how much ED is 2 meter. So AD square is equal to 2 meter square plus 2 meter square. It will be AD square is equal to 4 plus 4 is equal to 8. AD square is equal to 8. It will be AD equals root 8. That's the answer. Distance is equal to 6 meter and displacement is equal to root 8. Thank you. Second question on distance and displacement is to find. The second question is, there is a circular garden in which there is a fountain in between and a path around it, and it is given that the distance between the it is given that the distance between the fountain and the path is 7 meter, and said that a man travels around the path one round. So we have to find the total distance and displacement. Simple question given. 7 meter है क्या? 7 meter is the distance from fountain. वो ऐसे लिख रहा हूँ. So 7 meter है हमारा distance from fountain to path, and हमें find करना है total distance and displacement. So distance will be the, if it travels one round, the distance will be the circumference of the circle, that is 2 pi r. 2 pi r. So it will be we will take pi as 22.7 and radius is given 7. 7 and 7 are cancelled. 2 into 22 is equal to 44 meter. This is our distance. This is the distance, 44 meter. Now displacement. Some of students find it displacement is little bit tough to find as compared to distance. No, there are some questions like this question. If it's a circular path and it starts from the point A and take one round and again come to the point A, then our initial point and final point are the same. As I told you when I was starting displacement, that when initial point and final point will be equal, displacement is equal to 0. So thank you. So today's session is over. That's all for today. I will try soon to upload the next part. So thank you, and please like and subscribe video, and thank you for watching till end. Bye bye.